Hi everyone. So this talk is called GitOps and the Manifest Dilemma. And since you have chosen to attend this talk, it's probably because you have noticed that there are so many different templating tools out there. And new ones get released all the time, and they go in different directions, and you don't know how they fit into your current tool stack and how they work with GitOps. So this is some of the things we will be discussing today. And when we build the Kubernetes clusters, one of the first things we do is that we pick a GitOps tool, either Argo CD or Flux, and then we pick one or two different templating tools to use for our manifests. And whenever I say templating tool, I'm basically referring to any kind of tooling that takes some kind of template in, and then we have some values that we plug into this template in order to generate our manifest. That's the very basic model we're working with here today. And the reason I'm here talking about this is because I recently had this discussion with one of my colleagues. We needed to figure out what is the best templating solution for our company. Because my name is Dag, and I work in a platform engineering team inside Egmont, and I work a lot with GitOps and Kubernetes and that kind of stuff. And Egmont, that's the largest media company in Northern Europe, and we have 140 different companies in all shapes and sizes related to media and publishing and that kind of stuff. And the way we're organized is that we have something called Egmont IT, and this is where I work. It's like a support entity that helps the other businesses, and one of the things we do is that we build Kubernetes clusters, and we build them for all these other companies and provision software to them and applications and so on, and we're using Argo CD to do this entire thing, and also the developers deploy their applications through this instance. So now the question is, what is the best templating solution for our case? And as you know, there are so many different tools out there, and sometimes you can combine them, you can chain them together, and it feels like there's endless possibilities here. And I've highlighted 10 of them here on the screen, but you can probably think of 10 others that you would have liked to have added instead. But instead of going into a detailed comparison between any of these tools, because first of all, that would take way too long, and secondly, whatever I was going to say, it's probably going to be outdated very soon anyway, because a new feature gets released, and then then the pros and cons list kind of changes. So I thought it would be way more interesting if we could just take a step back and see if we can group these tools, see what kind of shared traits they have, and maybe put them into different categories to get a better overview of the entire landscape. Because if we do that, I believe that the next time a new tool gets released, we can already identify what kind of shared traits it have and figure out how it fits in with the rest. At least that's the goal. So I've chosen to reduce it or limit this presentation to talk about these 6 tools. This is the one I'll use as examples for this talk. It's Crossplane, it's Crow, it's Kustomize, it's Helm, it's CDK8S is a hard word to pronounce. And then we have Pickle. And before I forget, Crossplane, whenever I talk about Crossplane, I'm not talking about managed resources, like this feature where it can provision resources in a cloud provider and synchronize that back and forth. That is not what I'm referring to. I'm referring to Crossplane compositions, just to be precise here, which is their templating engine for generating Kubernetes manifests. So we're going to look at these 6 tools, and we're going to look at it through the lens of GitOps and see how it feels to work with in a GitOps setting. And the first 2 concepts I'll introduce you to here is this paradigm called out-of-cluster rendering and in-cluster rendering. And I think the simplest explanation here is just that the out-of-cluster rendering are basically just CLI tools, something you can execute on your machine, and you get an output, and it's usually deterministic, very simple to use. And then we have the in-cluster rendering tools, which are Kubernetes operators. It's something like Crow or Crossplane or KubeVela, something that needs Kubernetes in order to work. And yeah, these tools require that they read Kubernetes resources in order to generate other Kubernetes resources. But let me be clear here. This talk is not on how you structure the code and how you do the actual text replacement in the templates. No, instead we focus on where and when you render your manifest, because I think this is way more interesting in a GitOps setting. So let's run through the tools real quick, just so we have a basic understanding of how they work. We have all seen Helm and Kustomize. Helm is very basic. You have something called a chart, and this chart is your template for your manifest, and then you use values files to plug in values into this chart in order to generate your manifest. Fairly basic templating concept. The same thing goes with Kustomize. You have something called a base folder. This is where you store your, again, your template, and then you use these overlay folders where you overwrite certain fields inside the base folder in order to generate your Kubernetes manifest. We probably all know this. So then we have Pickle and CDK8S, and these tools are definitely way less known, so let me introduce them. So Pickle, it's a data templating language thing where you can write your manifest using your pickle code, and then you can convert it into real YAML using this pickle CLI. And that is basically all you need to know for this talk. And then we have CDK8S, which is a tool that allows you to generate Kubernetes manifest from programming languages, just like Python and Go and so on. So you have access to way more templating logic if you're using this kind of tool. And again, this is all you need to know about this tool for this presentation. And then we have Crossplane and Crow, and these tools are very similar if you look at it through the lens of GitOps. Crossplane has this concept called a composition, and the composition is basically just a thing that stores the template for the manifest, and then you use these custom resources to store the values that you want to plug into this template in order to generate your manifest. And the same thing goes for Crow. We have something called a resource graph definition. This is your template, and then we have custom resources again to fill in values into the template in order to generate Kubernetes manifest. And as I said, this is Kubernetes operator, so we're essentially converting Kubernetes resources into other Kubernetes resources. But this was the boring part. Let's now talk about how this works in a GitOps context. So here we have a very simple setup for GitOps, where we have a Git repository that contains some Kustomize or Helm templates stored in Git, and then we have our GitOps operator, either Argo CD and Flux, that reads this configuration, does whatever templating it needs to do, and then reapplies it to the Kube API server, and then you're done. So here, all the rendering is happening inside the the GitOps operator in order to render the stuff. And this is because both Argo CD and Flux have built-in support for Helm and Kustomize. But this is different from in-cluster rendering, where we have these custom resources that are stored inside Git, and then the GitOps operator just picks up these resources and applies them straight to the Kube API server. Here, nothing is being rendered by the GitOps operator. Instead, this step has been shifted towards a templating operator, at least that's what I'm calling it, symbolized with Crossplane in this case. So the templating operator picks up the custom resources and then renders whatever it needs to render, and then reapplies the final resources into the Kube API server, and then you're done. So you're taking an extra hoop here. So all the rendering is now happening in another component. This has some other side benefits. For example, that you can base your templates off other resources that exist inside a cluster. So if you like to do templating based on dynamic state inside a cluster, something that is updating, well, then you can do that compared to just comparing it with something that exists statically inside Git. But this is two different places you can do the rendering. You can also use the rendered manifest pattern. And this was something that was introduced a few years ago. I personally attended this talk from Nicholas at ArgoCon in Paris, where he introduces this concept. Check out that talk if you find that interesting. But let me simplify it for you here with this simple model, where we have a Git repository that, again, contains our templates, either for Helm or Kustomize. And then we have another Git repository where we're going to store the output. So in this case, we have an automation tool or some kind of pipeline that takes these templates and then it renders them and stores the output somewhere else in Git. So here we're kind of pre-rendering all our templates and storing it in Git. And this gives us more flexibility when it comes to tooling. For example, you could use the pickle tool or the CDK8S tool here to do whatever it needs to render and store it in Git. And if you do this, you end up with a flow that looks like this. You just have added an extra step in Git, and all the rendering is happening before it hits the cluster. This has some other side benefits, that you can do static code analysis and auditing and this kind of stuff based on the static information you see in Git. However, I don't know how reliable that is, because we all know that inside a cluster there's usually different kind of mutating webhooks that are going to change the resources anyway, so this output may not be that reliable for auditing reasons. But anyway, let's talk about health checks, because I think this is very important when it comes to what kind of paradigm you're picking, especially if you're considering using Crossplane or Crow. So with the simple out-of-cluster rendering tools, everything is being rendered before it hits the Kube API server. So that means that it's essentially the GitOps operator that is applying all the final resources to the cluster directly. So if a resource is failing, for example, a deployment, it's very easy for the GitOps operator to detect that it's failing, because both Argo CD and Flux have built-in health checks for this. So it's very easy to detect this and be notified as a user. But this is more difficult in in-cluster rendering, because now you have added a middle step here where you are creating these custom resources from your GitOps operator, and then it's up for the templating operator to generate the rest. So in this case, you need to ensure that the failing pods inside the deployment, that information is correctly being propagated up through the custom resource and into the GitOps operator. And this is not as simple as it may seem. I'll show you an example using Argo CD and Crossplane. So here we have an application from, shown with a UI from Argo CD where I have created a website. This is a website, it's just a custom resource I created with Crossplane. And the moment I click sync on this and it actually deploys to the cluster, it says it's green, it says it's healthy, everything looks great. But where's my pods? Where's my ingress resource? I'm not seeing anything. So in this case, I'm clicking the website, and then I see, oh, there's actually an error here. There's actually some issue with the composition here, and the templating is wrong. But Argo CD did not tell me, or does not know how to tell me that, because it doesn't know what to look for. So this is something we have to fix. But first, let's go back and actually fix our composition, and so the templating actually works. And after we've done that, we come back to the application, and then we can see that it correctly generated all our resources, so now we are happy again. But I could not see that before. Anyway, you are happy now, so you move on with your life, and a month passes by, and now you come back to the application again because you want to check out some logs, for example. And then you come back, and then you realize, wait a second, I have failing pods, and they've been failing for weeks, and I haven't noticed. Oh, again, it's because Argo CD does not detect that this is actually failing. It's the information that is failing is not being propagated up through the system. And since we were using Crossplane for this example, I could also have been using Crow. It would be the same kind of challenge. So since I'm using Crossplane, I go into my Crossplane composition configuration here and map the status of my failing deployment, like the actual status codes or status fields, into a new status inside my website here. So I'm mapping the failing deployment into this state of my website. So here I'm closing the first gap. But Argo CD does still not know how to detect if a website is failing or not. So I also need to go into my Argo CD configuration and then tell Argo CD exactly how to interpret the different fields inside my website. Don't worry too much about the implementation details here. The point is, I had to write a lot of code in order to actually propagate this information up through the system. I'll give you the same example for Flux, just as for the argument of completeness here. So same thing, if you first deploy this website with Flux, it will say that it's ready and everything worked out, even though we saw before that it's actually failing behind the scene. So again, we go in and we fix our Crossplane composition to make it work and actually correctly propagate the information. And then we go into our Flux configuration and again make a custom health checks that looks for the new fields that we have created. So in order to achieve something that looks fairly simple here on the screen, well, you need to write a lot of custom code that you need to maintain and you need to use brain power on. So keep that in mind. But how difficult this actually is depends entirely on what kind of combination you use these tools in. So it depends on your tool stack and so on. But keep it in mind. This is, I think, is a big deal of the in-cluster rendering tools. And it also has other consequences. For example, if you're using Argo CD's sync waves or Flux's depends on feature, these fairly popular features are like a progressive rollout thing where you can like set a certain order to the things you want to roll out. But these So the way they determine if they're allowed to roll forward is if the health checks is actually failing or not. So in order to use these features, then you need to be very careful with your health checks and really rely on them, because otherwise you're going to have a very bad time where either you're blocking the entire deployment process or you're just rolling through this whole deployment without actually using the depends on features. With that said, let's talk about something else, and that is, whenever I pitch the idea of GitOps to one of my friends or colleagues, they're usually kind of excited. They think it's a cool idea, right? And then people are usually excited about it. And then the moment they try it out, what is the first thing they complain about? They say something along the line of, wait, do I need to push to Git before I can actually see my change? And then they're all sad, right? We have all been here, and the sad truth is, yes, that is usually the case. And we are essentially all complaining about slow feedback loops. We are fairly used to this by now, that we have to make a change locally, and then we create a pull request for it, we wait for approval, and then we finally get it merged, and then after it's merged, we're waiting for the GitOps reconciliation step to kick in and actually do what it needs to do, and then we're done. Took a long time, and now it fails, and now we need to repeat and go back through that whole thing. Kind of slow, but the thing is, this is actually only the case in out-of-cluster rendering. In cluster rendering, you just extended this chain with an extra step where you need to wait for the templating operator to kick in, which again makes this whole process slower. And again, if it fails, you need to repeat and go back and so on. And how long this takes depends on how slow what tool you actually picked for your templating operator. So keep this in mind. But the thing is, you could also argue that this doesn't really matter, because this is going to be a bad experience no matter what. So what is maybe more important is the local rendering experience. How easy is it to validate the changes locally before I actually commit it to Git and see failures? And with all the out-of-cluster rendering tools, this is super simple. You're basically just executing your CLI tool, and then you get an output, and then you have validated your stuff. Very easy. But the in-cluster rendering, now things start getting a little more complex. First of all, Crow does not have this feature at all, so you will have to push to Git and go through this flow every single time. But I'm sure they will add this feature eventually. Crossplane has local rendering capabilities, and it does work, but in my experience, it's kind of hard to use, and I understand why it is. Because I usually have to provide it with so many different arguments to mimic what is actually happening inside Kubernetes. So the rendering capabilities is there, but it's not that user-friendly, but I don't really blame the developers for this, or the maintainers, because you need to mimic like a full cluster, and for example, if you're depending your templates off something that exists inside a cluster and you don't have that locally, well then you need to pull that and pull down the schemas and all that kind of stuff, which again makes things a bit complicated. And also you need to have like a container runtime installed on your machine because it needs to run containers and mimic things in Kubernetes and so on. Anyway, the point is that it's definitely more complicated using local rendering in an in-cluster rendering tool. Let's summarize some of these things with an example from my work, something that was very important when we had to make a decision at Egmont. So, as you remember, I work in Egmont IT here. We're deploying a lot of software to many different companies' Kubernetes clusters, and you can probably imagine that if I make a mistake, or when I'm doing some highly critical component upgrade, well, I'm potentially taking down multiple companies in one big swoop. And of course, I would like to avoid this, because my boss is not going to be very impressed. But I also don't really like to ask all these companies to put up some kind of status page saying, hey, we're doing maintenance and so on, because that takes too long and that's annoying. So what I like to do is what I call the good old Indiana Jones. See if I can switch a component in production without anyone noticing, right? And let's ignore the fact that he actually fails at this. But anyway, so I'll give an example using Argo CD and Helm, because that's what we're mostly using. So the first step I do is that I make the change locally, and in this case, just for the example, I'm adding this run as non-root as a field to my values file in this Helm. And after that, I run the CLI for it. I run the Helm template to verify that it correctly applies this change to my deployment I'm targeting. So far, so good. I have validated my change. The next step is that I commit this code to GitHub in this case, and then I'm waiting for my colleagues to review this code. But besides this value change you see here, we also have a tool that runs through, that mimics what Argo CD is doing by checking that Argo CD correctly can pick up the change and actually applies it to the right kind of application. So it's kind of predicting what Argo CD will do once it will be merged. I did another talk about that at ArgoCon last year, so check that out if you are interested in that. But usually these two steps are enough for 99% of the changes that we put into production, because we're validating the same thing 2 times, and that is usually enough. But sometimes you want to be extra careful. Sometimes you feel like your job is on the line if you accidentally mess this up, right? And sometimes you're updating one of these components that you're updating maybe 4 times a year. And I love the fact that I can go into my Argo CD, and then I can take the application I'm updating and putting it into a sync window, blocking it from synchronizing with the cluster. Then I can go back and I can merge my pull request. And after that, then I can actually go and inspect the change through the UI here. So I can click my deployment, and then I can see exactly what will happen once I actually synchronize and I actually deploy this to production. And if you paid attention here to the details, you can see that here I'm actually adding the run as non-root, which was also the case in the 2 previous steps. But here I also have allow privilege escalation to false and privilege equals false as well, which was not part of the 2 previous steps. And the reason for that is this view also takes mutating webhooks into account. So here I can get an even more accurate result of, or preview of what will happen once I actually deploy to production, which I think is extremely powerful when you're doing highly critical changes. So let's say I'm actually happy with this change. I just click sync and then I'm done. And I'm happy. But the thing is, I know you guys, and you're like, but wait, you're breaking the GitOps principles. And yes, this is illegal. But the thing is, we're following them 99% of the time, and 1% of the time we're taking the liberty to like stop the reconciliation and actually inspect something more carefully. Because do you know who doesn't care about the GitOps principles? This guy, my boss, he doesn't care at all. He cares about reliability and uptime, right? And the same goes for the customer. So it's fine to sometimes stop the reconciliation loop, if you ask me. So how would this have looked if I was using an in-cluster rendering tool like Crow or Crossplane? So the first step is that I pray that it supports some kind of local, reliable rendering thing, which may not be the case, but it depends on how good you are with the tool. Maybe it's a skill issue. And then you create a pull request for it, and then you merge it. And then you just pray that you didn't break anything. Like, there's not much else I can do in order to verify it. And that means, to me, if I'm updating a highly critical component using these tools, I always worry whether we end up like this. And this is kind of a big deal for me, at least. So the question is, which tools should you pick? Well, I can't really answer that for you, but as I see it, it comes down to the fact that if you use these out-of-cluster rendering tools, well, then you have access to very simple local rendering, and you can have, you have simple health check handling because it has built-in health checks for most things through your GitOps operator, and you don't have to fiddle with all these custom health checks from your the custom resources you're creating. And also, I always feel like I have this more control because there's more steps I can take in order to verify the change before it goes to production, as I just tell you. But in-cluster rendering still has a spot for sure. For example, if you're building your templates of live state that exists inside a cluster, that you have some dynamic things you're depending on, well, then this tool, this type of tool is great for that. Or you're trying to build a very fancy, advanced internal developer platform or some other cool buzzword that you heard at a conference. These tools are perfect for that. So here to finish the talk, I will give you a little guide, the one I follow myself. So what happens, let's say a new tool was released today. What should you do? So I suggest that the first thing you do is that you check, is this an in-cluster rendering tool? Because then I already know what kind of things I'm getting myself into, what kind of challenges may occur. And you can decide if you want that or not. If the answer is no, it's not an in-cluster rendering tool, the next question is it supported by my GitOps operator, either natively or through some kind of plugin? Then, if you have that, well, then you can use the very simple flow, the simplest of the flows I've shown, which usually integrates with most GitHub flows. But if the answer is still no, this new tool is not supported by your GitOps operator, well, then you're kind of forced into this rendered manifest pattern where you need to pre-render everything before it goes into your cluster. And I'm not trying to take anything away from this this paradigm here of rendered manifest pattern, because it has its pros and cons for sure, but it just requires more automation, more moving parts, more things that you need to maintain yourself, which is up to you if you want to take on that challenge. And with that said, thank you so much for your time. I really appreciate it. There is a link for feedback. I don't know if it actually works or not, but otherwise, feel free to just come talk to me afterwards if you have any feedback, or otherwise find me on LinkedIn and tell it there. The code examples is on GitHub. I don't know how much time we have. If there's a question. There's still 10 minutes. No, there's 7 minutes. Any questions? Can you please go to the microphone?
Yep.
Thank you.
So this one is more of a comment based on my own experiences, but we actually use a mix at my company of both out-of-cluster and in-cluster rendering tools for different parts of the stack. Our developers who are deploying the website are using out-of-cluster tools. They're easy to understand. You can see locally your changes, all of that. But on my internal development platform, we're using Crossplane specifically, so we have composites that deploy managed resources as well as parts of the cluster that are required to set them up. For example, we use EKS, so there's IRSA that's involved. So we're doing the same thing of rendering Kubernetes resources with Crossplane so that everything automatically works. And more importantly, it's all compliant with our security standards because it's always being reapplied at all the time through GitOps. But based on that context that's in the cluster, that's harder to get out of the cluster and into Argo.
Sure. Oh, thank you for the comment.
Hey, in an effort to speed up the feedback loop and to validate changes earlier in the cycle, is it viable to use something like local stack that can better mimic the entire cluster and other resources earlier on in the process?
I think I cannot really comment on that because it depends on what kind of in-cluster rendering tool, if it actually works with whatever.
Crossplane.
Yeah, but I don't know specifically. I've not tried that. I'm sure, like, if you can get that working, amazing. Like, I'm sure you can set up a very cool setup. My main point with that slide was just like, compared to Helm and Kustomize and the other tools, it's so much more work to mimic a Kubernetes environment locally where you're doing that. And you can for sure do it, but it's just like, do you want to spend your time on that when you're doing templating? I don't know. That's up to you if you have extra time on your hand.
Thank you.
Correct me if I'm wrong, is Flux not more of like a hybrid approach since the Helm operator is more of an in-cluster renderer, or?
I would not say so, because it's still basing it on what exists inside, outside in Git. And it's not like it's, like Flux is an operator, sure, so it is in cluster doing stuff, but it's, the rendering aspect is happening based on something outside the cluster, and it's not reading necessarily like resources inside the cluster for the actual Helm rendering. Am I wrong?
There's a Helm release CRD, so that's what I was thinking, like that's the Helm operator operates on that.
I think I'm misunderstanding the question then. Sure, you're using custom resources to actually do it, but it's not a classic chart thing, right, in that case? Like the chart exists somewhere, and it's not inside the cluster.
Yeah, that's fair. I'm just.
Okay, fair enough. Sure, your values can come from many different places, so sure, it can also work as an operator. Is there any other questions? Any comments? Yes?
So when we have multi-layer, like outside and inside, let's say Argo CD and the Crossplane combination, then so we have to write health checks of each internal component of that composite resource, right? That's the only way the health check will be propagated, right, to the Argo CD?
Kind of, yes. It's the same thing with Flux. Like, building status codes, status fields is kind of hard. So I love the fact that it's built into most GitOps operators to begin with, so I don't need to deal with that if I'm using the out-of-cluster rendering. And you're really in for a challenge if you're going to use the in-cluster rendering tools, because then you suddenly have to be the creator of these status fields.
Yeah, the problem is, let's say, I am stuck with using both. Okay, for example, at the high level, you will provision the cloud resources using the Argo CD and Crossplane combination, and Argo CD provision the Kubernetes resources. So in that case, when I'm provisioning the cloud resources, Argo CD doesn't know what is underlying composite resource, then I have to feed what one composite resource means internal, like a n resources. So then I have to feed that combination to this one. Any one of them failed means your composite resource is a failure condition kind of thing, right?
Yes.
Okay. Thank you.
You will end up writing a lot of custom code for this that you need to ensure works, and yeah. I'm surprised no one asked us what we actually picked at Egmont where I work. Well, the thing is, I chose to not include it here because I think it kind of ruins the storytelling, but we have a little bit of everything, which is a classic, right? So we use the in-cluster rendering with simple Helm charts for most of the things we build ourselves, but all the things that the developers use, or we have set up for them, is kind of a what's called a rendered manifest pattern, so they have easier access to see what's actually going on because they can just check it in Git. It was something that was implemented before I joined, but so we have that, and then we started evaluating if we wanted Crow or Crossplane as an additional thing for specifying like applications through an actual custom resource compared to just writing some raw values for a Helm chart. But considering how much extra complexity there comes from picking these in-cluster rendering tools in terms of all the health checks and in terms of so much more, then we're a little hesitant to jump into that, considering we're a very small team. And yeah, it's just a lot of extra work. But if you're a huge team and wants to take on the challenge, maybe it's great. One more question? he turned off the microphone because we're done, apparently.
Okay, I'll just yell. So first of all, out of cluster restering seems way less risky. So that seems like a pretty easy choice, especially as a security engineer, very risk averse. But between the out of cluster rendering languages, Kustomize and Helm, which one do you prefer? To me, I'm like, it seems like Kustomize may be better just because it seems simpler, and I'm also a fan of simpler things, but I want to get your perspective.
Comparing, Helm and Kustomize.
To Helm.
I loved Kustomize when I started off. I thought it was so simple. I really liked it. It got me into Kubernetes, but the more I use it, the less I like it, because I feel like it scales poorly when you have many environments. For example, a previous workplace I was at, we had 17 staging environments to like do some QA thing, and having 17 different kind of overlays and promoting changes and moving things up to the base and so on meant that I liked it less and less and less. And I feel like it's a pain to what is it called? To refactor Kustomize code and so on. So even though Helm sucks in many ways because it's just Go template and it's raw text.
Not for much longer. Helm 4, they're saying that it's not going to just be Go templates anymore. They're going to allow other templating engines. They released Helm 4 live at KubeCon this year. It was very exciting. Anyway,
Yes.
sorry.
No. Hopefully that turns out very well. But
Yeah, we encountered on the problem when you have duplicate